In this unit, we're going to discuss the mole and how to do proper molar conversions. The first conversion this video will go over is how to convert back and forth between the mole and particles. Notice our objectives. In this video, you will be able to define the mole, convert from moles to particles, and convert from particles to moles. Let's first look at our first objective, being defining the mole. The mole is a unit, just like gram or liter is a unit. Now I want you to think, what do we use the gram to measure? Well, we measure mass with the gram, or how much something weighs. Liters are used to measure volume, or how much space something takes up. The mole, on the other hand, that is used to measure quantity. Quantity being how much of something. Think about it this way. When you hear the unit dozen, what comes to mind? You think of the number 12. A dozen has 12 things in it. In the same way, the mole is also a unit that represents a quantity. However, it is not simply just 12. The mole, in fact, measures out 6.02 times 10 to the 23rd things. Those things could be either atoms or molecules. Now, 6.02 times 10 to the 23rd is written in scientific notation because it's so large. If we wanted to stretch that out, we would have to move the decimal 23 spaces all the way to the right. And fill all those spaces in with zeros. That's a rather large number. The reason why we use such a large number is because atoms and molecules are extremely tiny. You can't very well go into a lab and count out 12 atoms or 12 molecules. Now, this number was developed by a scientist named Avogadro, and therefore we call this number after him, Avogadro's number. Notice the picture to the right. This illustrates what this number actually means. Suppose I give you a bag, and inside was iron. And I said in that bag you had exactly 1 mole of iron. What that means is you have exactly 6.02 times 10 to the 23rd individual atoms of iron. Now that we know what the mole is, let's use this for some conversions. Suppose I give you 2.7 moles of silver, and I ask you to calculate how many individual molecules there actually are. What we do, 2.7 moles of silver. Set up your conversion with moles on the bottom and atoms on top. Moles has to be on bottom in order for it to cancel out. Now the relationship we just learned is that there are 6.02 times 10 to the 23rd individual atoms for every 1 mole. The moles cancel out, and now we can calculate. The most difficult part about this process is being able to punch this into your calculator. Grab your calculator and let's do it together. Type in 2.7, hit the multiplication sign, type in 6.02. Then when you get to the times 10 part, your calculator will have one of the following 3 buttons. Your calculator may have the button that looks like this, 2 capital E's. It may have a button that looks like EXP, or it may have a button that looks like times 10 to the x. Whichever button your calculator has, press that button, and then type in the exponent 23. If you did that correctly, your total answer with correct significant figures should be 1.6 times 10 to the 24th atoms. All right, let's take a look at another one. Suppose I have 4.67 moles of NaCl, and I want to know molecules. I'll set up my conversion with moles on the bottom and molecules, which is a particle, on the top. Since molecule is a particle, I'm still going to use the same conversion, 6.02 times 10 to the 23rd. Moles cancel out, and now I go through and I multiply. 4.67 times 6.02 times 10 to the 23rd. Your answer with correct significant figures should be 2.81 times 10 to the 24th. Let's give you a few to try on your own. Try 1.8 moles of copper to convert that into atoms, and 2.38 moles of lithium bromide into molecules of lithium bromide. The answer for the first one, with correct significant figures, should be 1.1 times 10 to the 24th atoms. The answer to the second one, with correct significant figures, should be 1.43 times 10 to the 24th molecules. Notice that it's molecules when there's a compound, and atoms when it's just an individual element. We have now gone from one way to another, moles to particles. Let's go the other way now and go particles to moles. You were given 3.4 times 10 to the 24th atoms of sodium and asked to convert that into the bulk unit moles of sodium. To start off, write out what you're given. 3.4 times 10 to the 24th atoms. Now that atoms is our starting unit, atoms needs to go on the bottom here in order to cancel, and moles goes on top. We know that there are 6.02 times 10 to the 23rd atoms for every 1 mole. Atoms cancels, and now we're left in moles. Take 3.4 times 10 to the 24th divided by 6.02 times 10 to the 23rd because it's on the bottom. Your total answer with correct significant figures is 5.6 moles. Go ahead and try the second one. You have 2.09 times 10 to the 23rd molecules, and you're asked to convert that into moles of H2O. We have 2.09 times 10 to the 23rd molecules. And we need molecules to be on the bottom in order for it to cancel out to get to moles. Same conversion, for every 1 mole, there is 6.02 times 10 to the 23rd. Molecules cancels out, and now we're left in moles. Your total answer, with the correct sig figs, should be 0.347 moles of water. Take a moment, try these, and then hit play to reveal the answers. If you have 9.7 times 10 to the 23rd atoms of zinc, you should get 1.6 moles of zinc. If you are given 1.87 times 10 to the 24th molecules of silver chloride, you should have with sig figs 3.11 moles of silver chloride. This concludes the video on converting from moles to particles and particles to moles.